In this lecture, we're going to learn about designated initializers. And this is a syntax that was introduced in C++20 to be super selective in which member variable we want to initialize in our aggregate initialization. Here we have a simple struct which we're going to use as an example. You see it has three member variables which are of double type. We have x and y and z, and you can think of this as a 3D point that we are trying to model in our program. We have a function here which we're going to use to print a component, but down here you see that we can really be specific in which member variable we want to initialize. But down here you see that we can really be specific about which member variable we want to initialize with our aggregate initialization here. For example, you can say that we want to initialize x by saying .x, and the data we specify is going to go in x. We can say y, the data is going to go in y. We can say z, the data is going to go in z. We can even skip elements. For example, we can say x and z or y and z, but one thing we cannot do is flip the order things were declared in our struct. For example, the order we declared our member variables in is x and y and z, and the order of initialization has to follow the same order. You see, we have x and y, z, we have x to z, we have y to z. We can jump around. For example, we can go from x to z and skip y, but we can't go in reverse order. For example, we can't say ZYX or ZX or anything. So in this example here, you see that we are saying XZY. So we are flipping the order here, and this is not going to be supported. If you do this, you're going to get a compiler error. But if you remember this simple rule, you can really be specific in which member variable you want to initialize. And one thing I should point out is that the members that you don't initialize are going to be zero initialized. So for example, in the second example here, y is going to be initialized to 0. If we print, we're going to see that. And in the third example here for C3, x is going to be initialized to 0 because we have skipped that. This is really all there is about designated initializers. You should know that this was introduced in C++20, so if you are using a C++ standard less than C++20, this is not going to work. But we are using C++20 in this course, so we can really use this. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is Designated Initializers. We're going to grab our template files and put them in place. Let's do that. And we're going to open this up in Visual Studio Code pretty quick by dragging and dropping here. This is going to open our main CPP file that we're going to clean up a little bit. And we're going to close the left pane here. We're going to put in our component struct pretty quick. So let's say component here. And we're going to say, let's say component. And we're going to put in our member variables, which are going to be double x, double y, and double z. And now we're going to go down and put in a function which is going to print this information here so that we can see this pretty easily. So we're going to say void print component, and we're going to pass this by reference. Let's say C for the parameter name, and we're going to print this out. We're going to say component, and we're going to say our member variables between square brackets here. We're going to say x is going to be cx, we're going to say y, and we're going to put this out, and we're going to say z pretty quick here, and we're going to put in our square bracket and end our thing with a new line of character through stdndl here. This is going to print our component. Now that we have this, we can set up a few components in our code. So we're going to say component C1, and we're going to specify which one we want to initialize of these member variables. So for example, we can say .x. Let's use aggregate initialization here and use curly braces. We're going to say .x to specify which one we want. For example, we're going to say x is going to be 5, y not, 5.7. And we're going to say .y, we're going to choose y here and say that it's going to be 8 6.2, why not? And then we can specify z to be something else. Let's say 5.2 here. And this is going to set up our component. Notice that we are following the order things were declared in the component structure. We can go down and even skip elements, so we can say component and say C2. And we're going to use aggregate initialization here. We're going to do, for example, we can say X and Z. We're going to say X is 6.2. And we're going to say Z, let's say dot Z, and we're going to put in 8.4. We can do this. Another thing we can do is, for example, skip X and say Y and Z. We can do this because this is going to be still following our order of initialization in our structure. So it's going to be going from Y to Z. So this is going to work. We're going to say component, and we're going to say C3, and we're going to aggregate initialize this. We're going to say Y, and we're going to put in 6.2, for example. This is going to work. And if we do Z.Z, this is going to put in a value of 5.9, for example. This is going to work. So these guys are working. What won't work is if we try and go against this order. For example, if we try and say ZYX, we're not going to get this to compile because we have to follow the order of declaration of the member variables in our structure. Let's give you an example. We're going to say component, and we're going to call this C4, and we can say Z, let's say dot Z, and try to say XY, and say Y here. And we're going to put in values. We're going to say Z equals 5.9. We're going to say X equals 10.4, for example. And we're going to say Y equals 6.89, for example. You can put in whatever you want. We just want to have some data in here. But the moment we do this, you see that we get a squiggly line because we can't really go against the order of declaration in our structure. This is what I want you to see. If we try and build our code, let's bring up a terminal and build using GCC, we're going to get a compiler error, and it is going to be somewhat descriptive. And it's going to say designator order for field component X does not match declaration order in component. I think this is pretty descriptive. We're going to know what we did wrong, and we're going to fix this. For now, we're going to comment this out because I want to make it super clear that this is going to lead to a compiler error. And we're going to print these points and show you that we have the data in. And another thing we're going to see when we print this out is that the data we skip is going to be 0 initialized. And this is very important to know. So we're going to say print component C1. We're going to print that. We're going to say print component and say C2, and we're going to put this out. And we're going to say print component and say C3 here and be done with our components here. If we build with GCC, this is going to build successfully because the syntax we used in C1, C2, C3 is supported. We are going to clear because the build is good, and we're going to run roster. We're going to see that we have the data in. For C1, the data is 5.7, 8.2, and 5.2. We have that here. For C2, you see that we have X and Z, and we have skipped Y, but we're going to see that Y was properly 0 initialized, and this is really cool. For C3, we skipped X, and we're going to see that X is going to be initialized to 0, and the rest is going to be the data that we had in our aggregate initialization here. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to try and show you that the aggregate initialization thing we have been talking about is part of a bigger scheme in C++, which is uniform initialization. Go ahead and finish up here and meet me in the next lecture.